Yeah, hi guys, how are you doing? Uh, Mr. Ibrahim is here with you. I'll be solving some those questions that you guys find difficult. So the first question here is this issue you are seeing. I've labeled the masses. Okay, let's start. Consider the two body situation at the at the left here. A 100 gram hanging mass, and that's our M2 100 gram, which is 0.1 kilogram. Is attached to a 325 gram mass M1. So that's our M1 there, which is 0.325 kilogram at rest. So our M1 is at rest on the table. The coefficient of friction between the 325 gram mass and the table is 0.215. Yeah. Determine the acceleration of the system and the tension in the string. Okay, now that is very interesting. It's actually a very simple question. You just take it one by one. We have two masses there. We have to compute the net force for each of the masses. Now, as we know, our net force is MA, and which will be for the which one did I do first? For the which one is this? Okay, for the M1, for the M2, sorry, for the M2, two forces are acting on the M2. The first force, first of all, the net force is the MA. So our MA is equal to the what? The total force acting on the system. Now the forces that are acting on the M2 now is what we are looking for. Now for the forces acting on the system, first of all, you have to get the direction of the acceleration in the system. Now in this system here, the direction of the acceleration is downward. Is the M2 will be the one that will be drawing the M1. I'm not sure you're getting it. The M2 will be the one that will join the M1 because the M2 is hanging freely while the M1 is sitting on the table, which will have a frictional force. So it's not free to move, so to say. While the M2 is hanging freely. So you see that the weight of the M2 is also downward. That means that what the direction of the acceleration is the same as that of the weight of M2, because M2 will act the weight of M2 will act downward. Since the weight of M2 will act downward, it will be positive there. Since it is the same, it is in the same direction as the acceleration of the system. So our weight there will be what? Positive. So we have our mg. Now the tension in the wire there, wire of M2, the tension in the string, sorry, is in the opposite direction to the acceleration, because when we talk about tension in a string, the tension will always pull the M2 upward. The tension will pull the M2 upward, while the tension will pull M1 towards the right. The tension is always around the pulley system. So the tension there is opposite to the direction of which the acceleration acts. So that will make the tension as a negative sign. So we have what MA equals to MG minus T. That is for the M2. Now for our M1, for the M1, the net force is also MA, which will be equals to, now in this case now, since the direction of the tension is towards the right, towards the pulley system, so the direction of tension is in the same direction as the direction of the acceleration. So our tension here will be what? Positive. Minus, in this case, the frictional force is not acting in the horizontal sorry, the weight is not acting in the horizontal direction, so it's not affecting the motion, and it's not even inclined, so it's not affecting any motion. Meanwhile, what's affecting the motion here is the frictional force. If the M1 is to move in the right direction, the frictional force will oppose it. And the frictional force, as we know, the frictional force always acts opposite to the direction which the motion tends to occur. So that means the frictional force will act leftward. So that will give it a negative sign. That will be what? Minus Our frictional force is what? U F equals to U R. So our R there is what? Mg. So we have what? U mu R, and R is M2. We have mu Mg. So that's our what? Second. That's the expression for the second, for the M1 there. So now let's put in our parameters. Our M for the first one, for the M2 is what? 0.1 kilogram. I converted, it was 100 gram, or if you convert it to kilogram, you have what? 0.1 kilogram. Hope you are following me. Okay, so let's move on. 0.1 A, that is M times A, which is 0.1 A, equals to M is what? 0.1. G is 10. I use 10 here. 10 meter per second square. So 10 times 0.1 of mg is what? 1 minus t. We call that one equation 1. Then for equation 2, then our m second mass is what? 0.325, and times a equals to t is what we're looking for, minus, if you multiply mu, our mu is 0.215 times our m, our mass, is also what? 0.325 times g 10. If you give you, that will give you total of 0.699. So you guys are good in mathematics. So if you solve continuously like that, you solve, you get your t, set to a formula, put it into one, blah 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 blah. If you continue solving, you get arrive at the acceleration. I'm very sure you can pause the video and solve it. If you understand, but I'm very sure you guys will get it. So you get your acceleration to be equal to what? 0.71 meter per second square. And after getting your acceleration, you can now put in this acceleration, the value of your acceleration, into any of either equation 1 or equation 2 to get your tension. Okay, let's move on. So I put in the value of A into equation 1, and then we put it to it, and we get our tension to be what? 0.91 Newton. And that is all. Simple as that. You feel me? Aha. Okay. Next question. What's up, Lula? How are you doing? I've missed Lula a lot. Akpan Lula. I've also missed Uncle Y. Moa. Uncle Y. Uncle. I also miss Adeokande. Uncle Ow. Uncle Ow. You understand that? So next question. Consider the two body situation at the right. At the right. It's not even right, it's even left. Wrong English. At the left. Anyone. A 3.5 times 10 raised to 3 kilogram crate M1. Our M1. Okay, our M1 is on it. A 3.50 times 10 to 3 kilogram crate M1. Okay. Rest on an inclined plane. The M1 is on an inclined plane and is connected by cable to a 1 times 10 to 3 kilogram mass M2. And that is the mass M2, which is hanging. It's connected to by cable. So let's move on. This second mass M2 is suspended over a pulley. As you can see it with your eyes. It's suspended. Okay. The incline angle is 30 degrees. So the angle of the inclination of the plane is what? 30 degrees. And the surface has a coefficient of friction of 0.21. So the coefficient of friction between the surface of the plane and the mass M1 is 0.21. Determine the acceleration of the system and the tension in the cable. Excuse me, let me check something. Okay, so let's continue. Okay. The inclined angle is 30 degrees. That is the angle between the plane and the horizontal surface. And the surface has a coefficient of friction of 0.10. Determine the acceleration of the system and the tension in the cable. Now, just as we did in the first question, we also have to compute our forces, the forces acting on the systems here, on the masses here. So to do that, we have to understand how the acceleration is moving. Now in this case here, the mass M1, in inclined plane, you have to understand that when the mass is on an inclined plane, that mass that is on the inclined plane should actually be able to draw the other mass, provided that the mass of the one on the inclined plane is more than the other mass. Now, if the M1 here is greater in mass than the M2, that should tells you that it will definitely pull down the M2. But if, for instance, the mass M2 is greater in magnitude than the M1, that means that the M2 will pull down the M1 and the direction of the acceleration will be in the direction of the M2. But in our case here, the mass M1 has a magnitude that is more than and greater than the M2, therefore the direction of the acceleration of the system will be towards the M1, downward. If that is the case, let's compute our forces. So the first one we computed here. Sorry, I computed here. I did it myself. You did not do it with me, so it's me that do it. It's my doing. So equation 1, the net force is ma, which will equals to, now let's recognize this mg sin theta. Now, since our acceleration of the m1 is downward, and since it is downward, our normal resolving of forces, the force in the horizontal direction is what? Mg sin theta. Mg sin theta. I'm sure you guys know how to resolve forces. So the force that is parallel to the surface of the inclined plane in the direction of the motion is what? Mg sin theta. Now, for every object on an inclined plane that has friction, since we know that the frictional force will always act to oppose the motion of an object, therefore the frictional force will be in the opposite direction to the motion of the object. So therefore we have a what? Negative sign. F equals to ur. So our u equals to an ur, where r is the what? Is mg cos theta. That is the value of r. Yeah. So minus mg cos theta. Then now our tension now, as I said earlier, the tension will always be towards the pulley system, that pulley there. So for this M1 here, the tension will be towards that pulley. For M2 also, the tension will be also towards the pulley. So now that means the tension in M1 is in the opposite direction to the acceleration of the system, so which we also have in a negative sign, minus t. That's equation 1. Then second equation for mass M2. In mass M2, the net force, which is ma, is equals to, in this case here, the direction of the tension is in the same direction as the acceleration. So the tension has a positive sign, while the weight is in the opposite direction, because the weight will act downward. The weight always acts downward. So that is minus mg. So that will give us equation 2. So you guys can just put in the parameters, blah blah blah. I used 9.8 here as our g. So put your mass, your blah blah blah. You solve. You get your equation 3 and equation 4. You can pause the video. Don't waste. You guys are good students now. You are a few ways, so you can solve that yourself. So here also from equation 4, we've gotten our a, right? Okay, this is our a here. So you can pause the video and check how I solve my own. So you get your a, then put in the value of a into 4. You get your tension to be 10,047 newtons. So that is the answer. Blah blah blah. I have one question again to give you. Let me check. How many minutes now? I can't check the minute. Where's the minute? I can't check the minutes. Okay, so let me solve one more question for you. I have one question here again. Now this is the question. See this question. in your test tomorrow, I will give you questions like this. So this question has, okay, let me read the question. The 7 kilogram box, this big one here, is attached to a 3 kilogram box, this small one here, by rope 1. The 7 kilogram box is pulled by rope 2, okay, with a force of 25 Newton. Determine the acceleration of the boxes and tension in rope 1. The coefficient of friction between the ground and the boxes is 0.120. I love this question. Just as if when we say, let's replace Farida with the 3 kilogram box and replace Kehinde Alao with the 7 kilogram box. Now, Kehinde Alao now hold a rope attached to Farida, that is rope 1. Then, let's now say Mr. Nafe now hold rope 2 attached to 7 kilogram box, which is Kehinde. So now, so since Farida is small, is rope 1, so Kehinde can draw. Then Mr. Nafe, which is also big, having 25 Newton, you also draw Kehinde. It's alright. That is also nice. So now let's start this. Let's solve our question here. Now this question is very technical, but it's and also very simple if you are calm. I'll try to explain with the best of my knowledge. If you don't understand, then I don't know. Somebody come and meet me in my DM and shouting, Uncle why, Uncle how, I don't want to hear how. Okay, you can come before you say I'm sending you away. You can come and ask me how and why. You're welcome. Okay, let's start. Now a 7 kilogram. What's the time? Sorry, 8:05. See, I'm coming. Let me pause the. Let me go and come back. Let me go and pray. I'm coming.